Hello, happy people. Here we go again. So we just graphed this, and it was in standard form right here. All right, ax squared plus bx plus c. Now we're going to deal with the same thing, which can be rewritten in vertex form. Okay, so we're going to see things that are written in vertex form. They're also parabolic. You could go ahead and rewrite these back into standard form as well. All right, so here we go. Here's how you do it. So let's take our vertex form over here. Take this over here so I can refer to it, show you guys it. So from vertex form, you can identify the vertex. That's why it's called vertex form. So the vertex for this thing is going to be at HK. All right, so we already can read our vertex off it. What is our vertex? Our vertex on this one's going to be 1, 2, HK. You're subtracting a positive 1 here, right? If you're adding, it would be a negative. If it was adding here, it'd be negative. But that's going to be 1. K is going to be 2. 1, 2. You see that? Okay, so we already know our vertex. Our vertex is at 1, 2. So remember, our vertex is right, that max or min is right at the axis of symmetry. So the axis of symmetry is at, it's going to be that. It's x equals 1. See how it's the x coordinate in the vertex. That's the vertex right here. All right, so once we have that, we can go ahead and graph these again. All right? So we know the vertex is at, right over here, I'll put 1, 2. I'm going to choose 2x values on one side, 0 and negative 1. And then I'm going to choose 2x values on the other side, 2 and 3. All right, so you're going to plug in a negative 1 here to start, right? Negative 1 minus 1 is negative, gives you negative 2 squared, which is 4, right? Plus 2, that gives you 6, right? Now I'm going to plug in a 0. I'm going to plug in a 0 here. 0 minus 1 is negative 1, right? Squared plus 2. Negative 1 squared is 1 plus 2 is 3. And guys, these are, again, when you find one side, it's going to be the same on the other side. That's the vertex. You see how, see that? You're always going to have, it's symmetric. So you see the way it works out. So you got negative 1, 6. You got 0, 3, and negative 1, 6 on one side. And then it's going to be the same distance away on the other side like that. It's symmetric. All right? So the axis of symmetry we have is 1. The vertex we had was 1, 2. The domain in this case, we'll go over that. The domain is going to be all reals because it goes forever in both directions. The domain is the inputs that you can use. So the domain is all reals, all numbers as far as we're concerned. And the range means the type of outputs you can get, the type of y values you can get. So the range over here, it has a minimum, right? The vertex is a min of 2 at x equals 1. So we can say it that way. So the range is going to be all values. I'll write it this way. We'll just say y is, you know what? I'll do it this way. No, we'll just say y is greater than or equal to 2. There are different types of notation you can use for that. I'm just making the video really quick, but all right, that was pretty fast. All right, let's do one more here. All right, so we can tell from before that, right, remember this, y equals ax minus h squared plus k. So we know the vertex over here, see how this is plus 3? So that's like having x minus negative 3, right? Plus 4. So your h over here is going to be negative 3. So when it's plus 3, it's negative 3 for the h, the axis of symmetry as well. Your k for the vertex over here is going to be 4. So we know the vertex is negative 3, 4. Okay? So we know that negative 3, 4 is the vertex. And then you're going to choose, so if we're at negative 3, 4, we have these x values and those x values that we're going to use. Negative 4, negative 5, negative 2, negative 1. All right, now we're going to go and we're going to, what I'll do is I'll go, and that also means our axis of symmetry is at the vertex. So the axis of symmetry right here is x equals negative 3. Okay, now I'm going to plug in values. If I plug in a negative 5 here, and I could plug in a negative 1 or negative 2, but if I find these, they're going to be the same as those going in the opposite direction, right? Remember that? All right, so I'm going to plug in a negative 5 there, so you get negative 5 plus 3 is negative 2. That's that squared, and you take the negative 1/2 of that, add 4. So negative 2 squared is 4. Times negative 1/2 is negative 2 plus 4. So that's going to be 2. So that's 2 right there. Now, if I plug in a negative 4 right here, you get negative 4 plus 3 gives you negative 1 squared, and then you have to multiply it by negative 1/2 plus 4. Negative 1 squared is 1 times negative 1/2 is negative 1/2 plus 4 is, yep, that's going to be 3.5, or right, or 7/2. So I'll just put 3.5 because I know you guys are going to like that better. So then it's going to be, remember, it's going to be symmetric on the other side, so those are going to repeat and be the same. So you got negative 4, 3.5. Negative 5, 2, so it has to be the same on the other side, right? And then this doesn't open up as much, or it opens down, but it doesn't open as wide as much because you have the 1/2 in front, and negative means it's pointing down. So yep, you have the axis of symmetry at x equals negative 3, the vertex, right, at negative 3, 4, and it has a max at max of 3 at x equals negative 3. The domain, any x value can be used. It goes forever to the right and forever to the right, left. You have a point for every x value. Domain is all reals, and the range is the y values you can use, and the y values are y is less than or equal to 4. All right, there we go. Second video done.